So we have an usher standing on a cliff elevated 50 meter high from the ground and shoot an arrow to the target which is 100 meter away beneath him. So the initial speed of the arrow is 80 meter per second, and if the usher shoot the arrow 30 degree below the horizontal, does it hit the target? So we want to know whether it hit the target or not. Explain quantitatively your answer means you have to prove your answer using calculation. Okay, so in order to hit the target, so what is the concept or the tips? In order to hit the target means that our arrow must move horizontally 100 meter. So in order to hit the target, our arrow must move horizontally 100 meter. So to answer this question, does it hit the target? We need to calculate our SX. We need to calculate the SX. Okay, so we need to calculate the axis. So again, this is a projectile motion, so we separate the motion into two, horizontal X and vertical Y. Start with the important concept. The acceleration for X is 0. The acceleration for Y is negative 9.81 meter per second squared. Then our U can be resolved into horizontal component Ux and also vertical component Uy. So our Ux is adjacent to the angle, so we are going to have 80 cos 30. Our Uy is opposite to the angle and the Uy is directed downward. So we have negative 80 sin 30. Then how far is the arrow travel? Horizontally is unknown, so we have Sx is question mark unknown. But then we know that to reach the ground, the arrow are going to travel vertically downward 50 meter. So the Sy will be negative 50 meter. Then how much is the final velocity as it reached the ground is unknown also. So we put question marks, and also the time travel, the time of flight also unknown. Okay, so we need to calculate the horizontal distance traveled by the arrow in order to know that is it hit the target or not. So maybe in order to calculate the Sx, maybe I need to know about the time. So I calculate the time using the component Y. I use the component Y to calculate the time of flight for the arrow. So I might use second equation. So refer to the Y motion. Sy is Uyt plus half Ayt squared. So our Sy is 50. Our velocity, initial velocity component Y is negative 80 sin 30 multiplied time, and our acceleration for component Y is negative 9.81 t squared. So I solve it using equation in calculator. So negative 50 equal to negative 80 sin 30 multiply unknown X. Okay, T tu saya jadikan unknown X minus 4.905 because 9.81 divided by 2 is negative 4.905 alpha X squared. Okay, so I get the X will be 1.101. So I have my time 1.1 second. So I already get the time of flight for the arrow. Then I can put it into the horizontal motion, X motion. So again, I use S equal to UT plus half AT squared, but I do it for component X. So I want to find the horizontal distance traveled by the arrow. The UX is 80 cos 30, 80 cos 30, and the time taken for the arrow to move in the A is 1.1. Okay, how about the acceleration for component X? The acceleration for component X horizontally, we do not have acceleration, so AX is 0. So solve it. So 80 cos 30 multiplied 1.1. So I'll get the horizontal distance traveled by the arrow is 76.2 meter. So it means that our arrow landing at a distance 76.2 meter. So our arrow is landing at a distance 76.2 meter, so it won't hit the target because our target is at a distance 100 meter away. So since our 76.2 meter is less than 100 meter, then we can draw a conclusions. We doesn't hit the target. Okay, the arrow not hit the target.